In this tutorial, we will implement a custom inventory system using entities and components. If you want more videos like this, don't forget to like, subscribe, and share. And if you want to access the code or the assets of this tutorial or looking for help, you can check our Patreon in the description. Let's continue with the tutorial. Hi everyone, in this tutorial we're going to do a custom inventory system, and so this is going to be an ambitious one. We have a bunch of stuff, and we are going to be using the new scene graph system. So we are going to make these items nice and tractable using entities. So first of all, as you can see, this is a highly customizable system. It's not just the UI and not just the positionings of it, not just the the textures, the look of it, but also you can just decide how many rows and columns this inventory is going to have, and depending on that, it will just resize itself automatically. And you can also decide on the page count as well. And let me show you really quick. So right now the value I set is 5 to 5, so you can see 5 columns and 5 rows, right? And I can just go between the pages, and of course they're all empty. And using this button you can drop the items, and then you can close like this, right? And now we have test buttons for you to resize the inventory inside the game. So I'm not recommend, so these are not to use on an actual production game. So when you are setting the inventory size of your game, you should set it from here. But while testing, you can use these buttons to test it quickly. And of course, make sure you are not decreasing the once your island is published. Make sure you don't decrease the size of your inventory, because if you do, your players might lose items, since all this is also all this uses persistence, and it saves all the inventory and stuff. And all of this is done really nicely for you to define items and use this system just by through the editor and through other devices. So let me show you a bit. So you can have actually first let me show you how you can change the size. So let's increase it a bit. So now I've increased the column size and decreased the row size, right? But as I said, I'm not recommending to use this use these buttons on a production, on a live game. Your inventory size should remain the same once the game is published, and you can update the size with updates, but make sure you don't decrease the size of it, or your players might lose items. Okay, so you can set items like this. So you can put the items in the scene, and when the players interact with them, it goes to their inventory, and they can click on these and move them in their inventory, and they can even move them through between the pages like this. And I can even do this, and now it's on the first page, and the other one on the third page. Let's get it here, and I can click this and the item will drop, and I can collect it again. And you can see the trigger here was triggering because we have a bunch of triggers to use this system. And so when so we have consume triggered. These are used to consume the items that a player might have, and these are the grant triggers to grant items to a player. But I'm getting ahead of myself. There's a lot to tell. Let's be more structural about it. So key ownership. So you can set up triggers like this to check ownership of an item. But first, let me actually show you how you can define items. which doesn't require any code. You define items in your game just by adding elements to this, and you set a texture for them, and then you set the item's prop asset, and you then set the name of it. So this is crucial. So basically the item is specified by its name. So you might by the system you might be required to enter the item name on different places. So the item name must be an exact match, right? Or it won't work. So we have a couple of example items here. So badge, chip, bioscanner, and stuff like that. And the texture is just a texture that's going to be used with the UI. And we have the prop asset. You can use anything with a prop asset. We just have a plane with a camera facing material on it. So it's just a regular building prop. You just go here, you just create blueprint class, and then you just create a building prop, right? So for all these we are just using the Fortnite's own plane mesh, and then we are using the camera facing material, which all of these assets will be available on our Patreon if you're interested. But this system doesn't depend on anything else. Like, you can just swap in, swap out with your own textures and meshes and materials. It's super easy. I mean, it doesn't even depend on any mesh or material. It just uses a prop, right? So any prop that you set, it's going to work, right? So we have the props set here like this. All of them are referenced here. So that's how you define an item, right? So items in the scene. So this is how you put items in the level. So you just put your prop in the level. So these are just the props. And then you reference them here. But also you need to tell, you need to write the item names here, right? So I could add another item chip here, another item prop chip. And then I would need to, write the item name again as chip. Doesn't matter, how many of the same item you have. They all need, if that's the same item, they're going to have the same name. So how does the entities come into play? So entity is created by the verse code, and it is directly referenced using an asset path. So you need to create an empty intractable. You need to create an intractable entity in this prefabs directory. So in your content directory, you need to create a folder named prefabs, and under that, you need to create this prefab _ empty intractable. Of course, we're going to give the UI set of this on our Patreon. So this is, you just you go here, you say enter the prefab definition, and it's going to be something empty. It's going to have no components, and you just go here, you just add a transform component, then you add an intractable component, and then you add a mesh component, and it could be anything, any mesh, but I just selected a cube, but it doesn't matter. For it to be properly interactable, I found out that you need to add a mesh, but you actually don't need to, but scene graph system is a bit acting a bit weird, so that's how I made it work. But make sure we don't want this mesh visible, so make sure it's enabled and queryable, but it's not collidable and it's not visible. Okay. And that's about it. You don't need to put its reference on anywhere on the device. It's going to be referenced from the code automatically. It's referenced by the code, and by creating a prefabs directory and putting this in here, you are basically telling the code where it is, and the name must match. So prefab _ empty intractable. So basically, the props themselves are for the visuals of the item, and to make the item intractable, we are spawning an spawning this entity and basically putting it at the same location of this prop, and this is all done by the code. You just put down props in the scene when you want to put like items in the scene. And then we have item ownership checks. So if you want to like you check if a player has an item or not, you can do that using triggers. So you just enter the item name to check, and then you reference the ownership check trigger. So this is the trigger that you are going to trigger to check if the player has this specified item or not. And if it fails or succeeds, these both triggers are going to be triggered by the custom inventory device, and not you. So these two will be triggered by the device, and they're going to listen to them. So if the player has the item, it's going to trigger the success trigger, and if doesn't have the item, so it's going to trigger the fail item. Of course, for each different item type, you need to have the ownership check trigger and the fail and success triggers. Which I did in the scene for all the 5 items. And then, so let me collapse that. And then item grant triggers. So this is pretty obvious. You just, for each item type, the item you want to name, you just name it, and then you just set the trigger to grant the item. So basically, when a player triggers this, they will get the specified item, right? And again, I have set it up for all 5 of these. And then item consume triggers. So we have this for, again, it's like grant, but just consumes. And it might not, if the player doesn't have the item, it might fail, but if it can, it will consume it. So inventory trigger, so input trigger. So this is just the input trigger to open the inventory. And this is the item pickup and drop triggered. So these are not so these are not typed per item. So these are general. So when anytime a player picks an item, any type of item, or drops any type of item, these are going to be triggered. And again, then we come to the UI stuff. So this is actually both the UI, but this is the size of your inventory, the row and the columns, and the page count. And then we come to the textures and the sizes of them, alignments of them. This is depending on the visual layout you want. You can customize them to your desire, basically. So let's use it. So right now you can see I have the badge and I have the chip. So I come to key ownership check. You can see from the top left that it says key not owned because I don't have a key. Let's check for key card. It says not owned. Badge, it says owned because I have the badge. And for the chip, it's going to say owned. And for the bioscanner, it's going to say unowned, not owned. Okay, that's great. So I'll just run on these and you'll see that it granted me all of them, right? From key to the bioscanner, and I can just drop them and get them up. And these are the consume triggers. So I have the bioscanner here, and I can go here and it will consume it, and I can go again, and item doesn't exist, it doesn't do anything. And I can just run on these, and you'll see that it all consumed all of my items. And this is a highly customizable, interactable custom inventory system. But there is so there is one crucial thing. This is related to scene graph's limitations right now. So since the verse device spawns these interactable entities, this entity at runtime, but for it to be able to spawn these entities, you need to at least put one entity. Actually, it could be any type of entity, but I just put this one because why not? Just drag and put in the scene. you need to at least put one entity in the scene for the device to be able to spawn entities, right? So this is just something you need to do for the scene graph to work. I don't know why. I mean, I have some ideas on why, but it's not that really important. Just a thing to know is that you just need at least one entity in the scene. And let me show you the code, right? So let's get to the meat of it. All right. And to remind you, we have the node here as well. We have the node here. Yeah. So we have all these classes, how that helps you define your data. We all seen that. So when we come to the persistent agent data, we, as you can see, we are storing the items as names with their names in an array, and then when storing them on the agent data, we're storing them with their indexes. And then we have the canvas, and then we have the state for the canvas, right? So this is kind of, I don't know why I have written this here. This is actually kind of, yeah, this is deprecated. That comment was deprecated. So you've seen all of these editables, so I'm just skipping them ahead. So here again, we are listening to the events, and then we are initializing a bunch of stuff, right? So if you have a late in it, this initializes the existing items in the scene. So why we have a separate function for this? Because between spawning an entity and then teleporting it, we just need to wait a bit for it to work. Or the teleportation that might fail a bit. Not really fail, but it could fail. It might visually fail, let's say. So that's why we do this. We spawn the entity, and then we basically teleport it, right? And then we so this is how we internally handle all the items being dropped and collected and dropped again with reusable item instances. So we don't destroy an item at all, so we just hide it. And when we are spawning an item again, if we have the same instance stored, we just reuse it. If we don't, we spawn a new one. But here we just spawn new ones because this is just the start of the game. Then we'll listen to the interacted event of the component. And this is the light teleport entity. So this is what we use when dropping items during the game. When an item is interacted, we just, if there is enough slots, if there's any place empty in the inventory, we are just putting it in the inventory, and we're saving the data, and then we're triggering the item pickup trigger. So this is the reusable item instance spawn. So this is where we look if there is an item that we have hidden before that we could use to quote unquote spawn for this one. If we can, we'll just reuse that. If not, we'll just spawn a new one. And if there is one, we'll just reuse it, and then we'll show it, we will teleport it, blah blah. So this is just open, but an old name. So we just open the inventory. If it's the first time, we create the inventory, and then we fill the current page. So that's what we do. Yeah. So it also remembers which page you have closed at. So if you close the inventory at the second page, when you open it again, the second page will open instead of the first page. So this is the ownership trigger. So it's we just look through all the items. If you find it, we trigger this. If we don't find it, we trigger this. So this is the on item granted function. This is called when you trigger the grant trigger, and we just, if there's any available slot, we just give that item. And again, with the consume trigger, we just look if the player has that item. If so, we just consume it. In the player joins function, what we do is we just initialize the agent data. So these are the page button events where we update the page, and then we update the inventory inventory UI, the slots. So this is the drop button. So depending on, so we look at the item type. So we decide on the spawn location just a bit forward ahead of the player, and then we spawn the item at that location, and then we decrease, we consume that item from the player, and then we update the UI, blah blah. We trigger the item drop trigger. Close button, this is straightforward, we just close the UI. So this is the inventory slot logic. So we look for the collect slot, we look if there's any item on it. If there's we also store our previous click state. So first of all, if there is no previous click state and this inventory slot is empty, we are not doing anything. But if there was a previous click state, we are going to do something. Rather, doesn't matter if this slot is empty or not. So we just switch the contents of the two slots. So even if the second one is empty, it works. We just make the previous one empty, or we just swap the contents of these two slots basically. And also we make if we don't have a previous click, we make the first click have an outline around the slot. So that was the orange outline you have seen on the inventory UI. So here we actually just have a bunch of prints to make sure that it's working as intended. You can if they bother, you can just comment them out. But they won't exist in the production game, so it doesn't matter. So this is the fill inventory page. So this is just looks at the state of the agent data. So which page the agent is currently on. So it's just going to go and reset all the slots on the UI, and then fill the contents of the UI slots using the currently set page. And these are a couple of utility functions that gets the item from name or gets the item index from name. Basically just linear search. This is just creates the agent data. So these are conversion functions between the two data types. We have the save data, which is important to do player is active, or it makes a runtime crash. Then we come to the canvas creation. So this is just for positioning, and this is the actual canvas creation. We have the inventory background. So depending on all those parameters, we set the size of the inventory. We put the page text, and we have all the data for the buttons. So in a loop, we create all the buttons. Not all the buttons, the buttons except the slot buttons. So the page buttons, the drop and the close button. And then we come all the other slot buttons. So we know the size of the inventory. So we create how much we need. Create as much as we need, and we use the create inventory slot canvas, which is just two textures on top, and then three textures on top, and then a button on top of them. So we have the slot background, we have the item texture, and then on top of them we have the outline texture for the slot, and then we have the button, right? And we also listen to the buttons event. It's rather maybe one of the longest ones we have written so far, and considering that this is mostly not UI, it's actually a bunch of logic, yeah, so it could be a lot, but it's definitely a strong starting point for many advanced systems you might even want to build on top. So let me show you all of that by scrolling up slowly. All right. Yep. We have a bunch of prints here. All right. Reusable items. Yep. The test buttons, and then we have our bunch of editables, and then our, basically our container classes. Okay. And we have tooltips, so if you come over to the device and look over to the like all items, you will see the tooltip message, and if you come to items in the scene, you'll also see the tooltip message. The one last thing is I didn't show you the persistence, so you can see that we have 2 items, and if I close the game and start it again, you can see that items are still there, and they're real items, interactable items. Yeah, there is a bunch of ways that you can use this, using by just even triggers. So that was all. To access the code or the assets of this video, you can check our Patreon. So thanks for watching. Like, subscribe, and share if you've enjoyed. And also leave a comment on what tutorial you would want to see next. See you later.